Good morning, good afternoon, good evening, wherever you are. I'm your host, FD for SageFab.tv, and in this video, we are going to be applying our DUA or our risk evaluation to Lagrange or Lagrange. I'm going to call it Lagrange. Some people say Lagrange, or maybe there is a French element to it. I'm not sure. Anyway, Lagrange is a decentralized cryptographic protocol designed to enhance blockchain scalability, interoperability, and verifiable computation through zero-knowledge proofs, and it comprises two main components. But before we even get into those components, some housekeeping first. In this video, we are not providing you with any financial advice. Please do your own research. Crypto is risky, and you should always seek someone who's actually trained to give you financial advice. And if you are from the UK, this video is not for you. This is just for educational as well as entertainment content, especially for those from the rest of the world. That said, let's jump back to Lagrange, a decentralized cryptographic protocol designed to enhance blockchain scalability. The first main component is ZK Prover Network, which is a decentralized network that generates ZK proof for various applications, including rollups and decentralized applications or dApps. It operates as a marketplace for on-demand proving services, enabling diverse use cases. The second component is the ZK Compressor, which is an infrastructure that allows developers to perform intensive off-chain computations and prove the results to smart contracts on-chain. This enables applications to move heavy computation off-chain while ensuring cryptographic integrity. Let's move on to the key features for Lagrange. The first one is zero-knowledge proofs. Lagrange leverages ZK proofs to enable trustless and secure cross-chain interactions without relying on traditional bridges or messaging protocols. Next, you got the hyper-parallel ZK core processing. The ZK core processor facilitates verifiable computation of blockchain data at a big data scale directly from smart contracts. And the third feature is its state committees. Its state committees serve as a ZK Lite client protocol for optimistic rollups, providing a shared and permissionless zone of security for cross-chain bridging and messaging protocol. This state committee, or LSC, is a zero-knowledge Lite client for optimistic rollups that settle on Ethereum. Let's move on to the value propositions for Lagrange. It aims to provide a scalable and secure infrastructure for decentralized applications by enhancing interoperability, improving scalability, and ensuring security. Lagrange state committees enable a fast mode for protocols to bridge from an optimistic rollup without waiting for the challenge window to close. This especially addresses a main pain point around cross-chain message latency. And if you want to know more about these parts, I'll leave some links for you to go and do your own reading, and it is quite fascinating. I found this fascinating when I was reading the report itself and some of the documents supporting this report. And what makes Lagrange's Prover network unique? Well, first of all, you've got the high guarantee of liveness. While ZK proofs can guarantee the validity of a computation, there is no inherent guarantee of liveness of when a proof will arrive to a blockchain. However, with Lagrange's Prover network, operators run provers and commit to generating proofs within a given time period and collateralize the commitment with capital. Failure to generate a proof on time results in a penalty in the form of slashing or non-payment, which incentivizes operators to perform as promised, resulting in high liveness guarantees. The next reason why Lagrange's Prover network is unique is around its favorable cost structure. On top of being the first live decentralized ZK Prover network, Lagrange's Prover network also utilizes a novel architecture that benefits users. For example, applications and developers using the generated proofs as well as provers, that is those that are running computations to generate proofs. By deploying on Eigenlayer's low cost of capital environment with restaked ETH, users are required to pay less for liveness than alternative staking sources. The next reason why Lagrange's Prover network is unique is around its hyper-parallel ZK core processor. Lagrange's ZK core processor allows developers to access verifiable compute at an extremely large scale by lifting intensive computations off-chain and generating ZK proofs of the results to bring back on-chain. Lagrange's ZK core processor is the first proof type deployed on Lagrange's Prover network. What makes Lagrange's approach particularly unique is the ability to break down and distribute computational tasks to Lagrange's decentralized Prover network, which consists of an unlimited set of provers restaked on Eigenlayer. This means that compared to other ZK core processors on the market, Lagrange's ZK core processor can handle a much larger scale of computations and can generate the results and proofs significantly faster. And the next reason why Lagrange's prover network is unique is around its granular proving marketplace. Here, Lagrange's proving network enables operators to generate different types of proofs based on requested latency and hardware preferences. The proving network architecture generalizes to different categories of proofs, including data consumption, database construction, data ordering, and so on. The hyperparallel nature of the network allows segregation and pricing per proof category, leading to a two-sided marketplace where complex queries are met with predictable proof categorization and generation. Now, as part of our DYOR evaluation, we do evaluate 13 elements in decentralization, security, scaling, interoperability, the project team, age of the project use cases, as well as the tokenomics. And to kick us off, our DYOR risk evaluation toolkit, it's decentralization. Lagrange operates as a decentralized protocol with its ZK prover network and state committees managed by a distributed set of operators. The protocol leverages eigenlayers risk-taking mechanism to secure its network. As far as token distribution is concerned, the LA token, which is the ticker symbol for Lagrange, has a total supply of 1 billion tokens with a hard cap distributed as follows. Got the community and engagement is 34.8%. Early contributors were allocated 25.4%, investors 18.5%, foundation 11.3%, initial airdrop 10%, and tokens allocated to early contributors and investors are subject to a 1-year lock-up period followed by a 2-year vesting schedule. And as far as we are concerned, this setup or this token distribution favors insiders at a ratio of 55.2%, which means it's really not favorable to the wider community. Moving on to security, as of now, there is no publicly available information regarding third-party audits that we could find for Lagrange smart contracts. The project has not undergone a static audit or something like that as far as I'm concerned. If I'm wrong, let me know in the comment section. And there are also no reported bug bounty programs that have been announced. However, through its ZK technology, huge data is computed off-chain with attestations without sacrificing data integrity and confidentiality. So I think the users themselves will be somehow secure in their interaction with Lagrange's protocol. Moving on to scalability and interoperability, Lagrange's architecture is designed to scale and interoperate across multiple blockchain networks. The ZK core processor enables off-chain computation, reducing on-chain load and improving scalability. Lagrange's state proofs allow for non-interactive and aggregatable verifications of cross-chain states. And unlike traditional monolithic ZK prover networks that rely on single gateway models, Lagrange's design is modular, supporting multiple independent subnetworks with dedicated bandwidth that collectively form a prover network of prover networks. This approach allows any blockchain rollup or application to connect through customizable standards and empowers developers to scale without bottlenecks or input-output constraints. In other words, Lagrange's ZK prover network enables dynamic, infinitely scalable proofs for everything, including large-scale rollup ecosystem. Moving on to social media presence via X, formerly Twitter, we are looking at approximately 9,200 Twitter followers or X followers, formerly Twitter, and via Discord, we are looking at approximately 104.5 thousand Discord members. So a lot of Discord members and not much on X, formerly Twitter. And according to publicly available information, there are between 22 to 25 team members. As for use cases, we start with the LA token. It's used for staking, for governance, and payment for proofs. And as for the protocol, it's used for cross-chain decentralized identity or DID or DIDs, as well as for cross-chain voting and verifiable AI inference. And strength for Lagrange protocol, well, you got to give it for its innovative architecture, its decentralized governance, as well as the diverse use cases. And weaknesses, there is always a question mark when a protocol does not have publicly available audit reports from reputable audit firms like CETIC and Hubble and Heiken as well. And I also think Lagrange protocol is quite a complex beast, just like Eigenlayer. Takes some understanding to actually get to the bottom of what they are trying to achieve. But there you go. And my final thoughts before we move on to the scaling and scoring part, here are my final thoughts on Lagrange's protocol. It presents a promising approach to enhancing blockchain scalability and interoperability through its innovative use of zero-knowledge proofs and off-chain computation. While the protocol offers a range of compelling features and use cases, the lack of publicly available security audits may warrant caution for potential users and investors. Now, let's move on to the scoring part, where we are going to be applying scores from 0 to 10 across the 13 elements. And a quick rundown of those 13 elements once more. You've got decentralization, security, scaling, interoperability, the project team, social media presence via X, formerly Twitter, as well as via Discord, age of the project use cases, tokens issued at project launch, total tokens in circulation at the time of recording, recording, maximum tokens available, as well as insider token allocation. And to kick us off is decentralization. We gave Lagrange 7.5 points out of 10, on security 7.5 points out of 10, scaling 10 out of 10, interoperability 10 out of 10, project team 7.5 points out of 10, social media presence via X, formerly Twitter 7.5 points out of 10, social media presence via Discord 7.5 points out of 10, age of the project 2.5 points out of 10, project use cases 7.5 points out of 10, total tokens issued at project launch 2.5 points out of 10, and tokens in circulation at the time of recording 2.5 points out of 10. Maximum tokens available 5 points out of 10, and insider token allocation sitting at above 55%, way above our minimum threshold. We are going to give Lagrange 0 points out of 10. There you go, ladies and gents, the scores we've allocated to Lagrange's project or Lagrange protocol as part of our DIWA or our risk evaluation assessment. Any thoughts? Let us know in the comment section. And if you were to apply some scores to these 13 elements we use as part of our DIWA or our risk evaluation toolkit, which scores would you actually allocate to Lagrange's protocol? Let us know in the comment section. The aggregate score for Lagrange protocol comes up to 77.5 points out of 130, which puts Lagrange within the could go to zero category like many projects we've assessed on this channel. Any thoughts? Let us know in the comment section. Do I hold Lagrange LA token? Not at the moment. Is it something I'll be interested in? Yes, somewhat, because I think the tokenomics for once, not the distribution, but the cap at 1 billion, it's a lot better than eigenlayers. So I think there's something there. And it is also somehow understandable if you actually spend time on it, try and understand its architecture. So I think, yes, it is a project that interests me, but at current valuations, it might still go a lot higher. I think I'll have to wait until the next bear market. That's my angle. That's my game plan for the LA token. What about you? Let me know in the comment section what your thoughts are. Until the next one, guys, FD for Sage5.tv signing out for now. Bye.